So who here considers themselves truly cloud native? No? What are you doing here? Any edge native folks here? No. Okay. Okay. Well, I think if you're here, you are really cloud native and you are heroes for me. But anyway, to more practical questions. Who here knows what Istio is? Okay. Using Istio in production? A few hands. Very nice. Cool. Istio aside, who here has heard about service meshes in the last year? More or less the same people? Okay, I see. Well, you should have, and if you haven't heard about service meshes, then after today's talk, you can say that you've heard about it. And well, the tech, the service mesh tech, has been buzzing like crazy, to be honest. And when something like that happens, we as intellectuals should start asking some questions, and that's what this talk will be about. Trying to ask some questions about service meshes and provide some adequate answers for these questions. So, but first let's get acquainted. So this is me, Anton, or as folks call me, Ant Weiss. This is my Twitter handle. Please do connect. In the last 15 years of my career, I've been trying to help companies improve the way they deliver software. And this is the company, my company, where I try to still do this in the last 4 years. Now, it's from this angle, from the angle of software delivery, that I got very interested in this new tech called the service meshes about 2 years ago. So we started looking at Istio and building some pilot projects, and I even built my own canary release controller called Birdwatch based on Istio. And then I built an Istio workshop. And then about 3 months ago, I joined a community called Layer 5, which is dedicated to researching and promoting this new family of technology called service meshes. And the talk is basically the result of all that. Now, as I said, the service meshes have been buzzing like crazy. Okay, and well, this talk will be an attempt to summarize what all of this is about, but before we understand how we got here, let's see how it all started. So our story starts a little less than 4 years ago with this blog post from William Morgan, the CEO of a company called Buoyant, which talks about the first release of an open source project called LINKERD. Who here have heard about LINKERD? Okay. More or less the same folks who raised hands when we were talking about Istio. Cool. So basically what the post was talking about is that William, along with his co-founder Elliot, they were both Twitter graduates, ex-Twitter employees. And Twitter notoriously has its backend enabled by a multitude of microservices communicating with each other. And in order to solve all kinds of weird problems that they had in these services communicating, they've built their own open source library called Finagle. And but the library had its own issues because, first of all, it was meant for the JVM stack. And well, it was a library, so you had to manage dependencies. So when William and Elliot left Twitter, they decided that all the features that this library provided could be better provided and become more useful and usable if they wrap it in a proxy of its own, a standalone proxy. Okay, and that was what LINKERD was about. Okay, a standalone proxy that should be running in a lot of places in our system, managing all the connection among our services. Okay, Twitter-style operability for microservices, basically. Okay, LINKERD was a revolutionary project, and by the way, this post is, as far as I know, the first place where we see the service and mesh, these two words, in conjunction. Okay, so basically, this is the first time this concept appears. But LINKERD, while being a good project, it was backed by a very small company called Buoyant. So while some engineers loved it, it didn't get really a lot of traction. Half a year later, another important thing happens, and that's this post from Matt Klein, the tech leader at Lyft, the ride-sharing company, which talks about Lyft open sourcing their C++-based, very performant proxy called Envoy. And what this post talks about is that this proxy, well, first of all, it was already running at Lyft, so it was kind of battle tested, but it was also based on Matt's work, previous work at Twitter. So basically what we can see is that service mesh is a literal example of a Twitter-driven technology. So Envoy wasn't marketed as a service mesh. But half a year later, we suddenly discover there's a new project backed by Google and IBM and Lyft called Istio, and that's when we finally start hearing about service meshes and things start heating up. It's the first robust service mesh for microservices built on Envoy and targeted at, the magic word comes here, Kubernetes, right? So that's why we're all talking about Istio today. Well, that was like this announcement about Istio actually happened 2.5 years ago. Now, 2.5 years later, what we have is this. Well, first of all, Istio has reached version 1.3. The first production-ready version of Istio 1.0 came out a year ago. It was production-ready, right? But, well, many bugs were fixed, performance was improved, and in December last year already Google started making Istio available as a managed service on Google Container Engine. So now Google is not only developing and promoting Istio, they're also selling it, which was quite expected. LINKERD, we now have LINKERD 2.0, which is a different project, and we'll talk about that later. And we also have more competition in the form of HashiCorp CONSUL, which is now called CONSUL Connect, and now also supports Envoy as a sidecar proxy. But the things started really heating up in the last 2-3 months when we suddenly saw a few more projects in the same space, namely Mesh from the company called Containers, the makers of traffic load balancers that some of you may know, and KUMA, which comes from a company called Kong, the makers of an API gateway with the same name. And finally, all this resulted in a new and very special and interesting project hosted by CNCF called Network Service Mesh, which, while being a different beast, is definitely related to all of this. Now, we'll discuss all of this in a bit more detail later. Okay. In addition to that, of course, the companies that sell software for money are always a part of the party, right? Because when there's hype, we smell there's money. And we see that there are service mesh implementations from different large names and some newcomers. We see AWS here, and there's Aspen Mesh backed by F5, and there's VMware with NSX and other projects. But we're, of course, more interested in the open source things that are featured on this slide. Okay, now when there is so much buzz around some new tech, as I said, we should start asking questions. And as I see it, there are 4 main questions. Somehow, yeah, it's like in Leon's talk. There are 4 questions. Probably, again, yeah, some kind of a Jewish thing. So, so we should first of all ask ourselves, what the hell is a service mesh, right? How come we didn't need one 2 years ago and suddenly everybody needs one? Now, why the hell do we need this? After we understand what that is, do we even need one actually? And if we persuade ourselves that we do need one, then with the amount of options that suddenly appeared, which mesh should we choose? And one of the considerations when choosing, but not the main consideration, sometimes we choose because other considerations, but once we choose, we'll have to think what will it cost us to implement this, compute power-wise, or knowledge-wise, or process-wise. Okay, so we'll try to answer all of this. And we'll start with the question, what is a service mesh? So I have a diagram here, and we'll start with the definition that's, while conceptually correct and important, is also practically not that useful. The thing is, the moment we write and run a microservice system, we invariably get a service mesh. Because all the multitude of connections between the services, all the intertwining of communication channels through which the data flows from a service to service, they actually form this mesh, right? Or more correctly, the upper part of this diagram called the service mesh data plane. Now, the practical approach in dealing with all this complexity is what we today call the service mesh. In that approach, we're handling all of these connections with the help of a mesh built of lightweight proxies, which reside near each one of our services. Istio, the first most popular mesh, was based on Kubernetes. So in Kubernetes, this is of course implemented as sidecar containers residing in each one of our pods, intercepting all the traffic that goes into the pod and out of the pod. But putting a sidecar near each one of our services is of course interesting, but the real superpower comes from the lower part of our diagram, which is called the service mesh control plane. What would Freud say about this? In this part, we usually see components such as some kind of a user interface, a graphical user interface, a CLI, and because we want this programmable and dynamical, then probably an API. Some kind of a component that would deal with observability of the network. Some kind of a policy engine that would define what is allowed and what is not. And finally, as we want our services to communicate in a modern, secure way, according to modern security standards, there would be a security component, basically an MTLS provider in charge of generating, rotating, and distributing certificates. So this is how most of service mesh implementations are based. This is a point where it's important to talk about a controversial relationship between meshes and all kinds of gateways, like API gateways, ingress and egress controllers, and different kinds of load balancers. So there are folks in the industry who say that this distinction between east-west traffic and north-south, south-north traffic, it should be erased, right? Because no matter if we talk inside of our system or we talk to the services outside of our system, it's all the same. We always talk to some ephemeral, unreliable, and probably hostile entity. And we should manage it in the same way, with the use of the same control plane, the way Istio does it, by the way, where ingress and egress gateways are the part of the default installation. Now, you may believe this to be true, you may believe this to be not. Some folks say, no, these are different concerns, we shouldn't be mixing oranges with apples. No matter what we believe, today, these are still different concepts. So when we're talking about a mesh, we usually mean the east-west traffic, while gateways take care of north-south traffic. But paradoxically, maybe your way into the mesh will lie through a gateway. And that's probably because when we go to an unknown territory, it's easier to take a known path. And the territory is unknown because, and we now understand what a service mesh is. We understand how it is different from a gateway. But still, what is it about? Is it about observability? Is it about security, maybe? Is it about routing? Not totally clear. So to provide a more predictable answer to all of these questions, and in an attempt to somehow control the feverishly growing market, a group of companies led by Microsoft and Red Hat stepped up about half a year ago with a proposition of creating a spec called Service Mesh Interface, with the proclaimed goal of defining a basic set of functionality that any service mesh implementation should provide, so we as users know what to expect. And also a layer of abstraction, an API language through which we could talk to all the meshes at once, and the meshes could talk to one another, and we could probably connect the meshes with one another. And an unproclaimed goal of providing some counterforce to the forces that we may feel that are trying to dominate the market. Because when we look at the logos of the companies in this group behind the service mesh interface, we surprisingly don't find some logos that we expect to see here, namely Google, IBM, and Lyft, the companies behind Istio. When I asked Gabe Monroy, who is leading the SMI effort at Microsoft about this half a year ago, he said that them joining the SMI initiative is just a question of time. About half a year passed. Google and IBM are selling Istio on their clouds, and, well, nothing else has changed, which means that the future of the SMI is not totally clear, but still, it provides a very nice way of trying to analyze what is it a service mesh is good for. So let's look at the spec. Now, basically, the SMI defines 4 groups of APIs, with the first one of them being traffic spec, defining what is it that our traffic looks like, what kinds of traffic could there be in our system. So this is an object belonging to that group, which defines a route group. Basically, it says our services can have 2 kinds of routes, one of them being metrics, listening on /metrics, and dealing with GET requests, and another one called health, listening on /health, and dealing with all kinds of methods. Now, once we've defined what kind of traffic we have, we can start defining who is allowed to talk to whom through these routes. So now we have an object called traffic target that defines then whenever there is traffic going to a service that's identified by service account service A, going to port 8080 on a route called metrics, which belongs to the route group the routes, we allow that traffic to come from a service that's identified by service account Prometheus in namespace default. So basically, we're saying Prometheus can read the metrics of our services. The next group of APIs is specifically close to my heart because I care about delivery. And this is the API group that allows all of the progressive delivery techniques such as blue, green, canary, etc., etc. This is traffic split. This basically says whenever we talk about service called MyApp, it can have 2 backends, one of them being version 1, the other being version 2, and we can define the weights of of the traffic that each one of these backends receives. So here we're spreading them 50-50, allowing for some kind of A/B testing, probably deciding which version provides better performance. And finally, the last API group is traffic metrics. So now that we've defined what kind of traffic there is, and we've defined who has rights to use the traffic, and we've defined how we split the traffic, we want to start measuring how all this results, how all this influences the traffic. So we're defining the direction of the traffic. So for example, here we're measuring the traffic from pod foo something something to pod buzz something something. Or we can define that it goes the other way, from buzz to foo. And when we've defined that, we can start defining what we're measuring about this traffic. So for example, here we have different percentiles of response latency, success count, and failure count. Now that we have the SMI at our disposal, can we finally say what the hell do we need a service mesh for? Well, a lot of things, but let's try. So first of all, once we have those proxies everywhere, and we have the spec, and we have the access control, suddenly our network connections become manageable, right? The manageability of the network tissue. Then, once we have the proxies everywhere and we can measure the traffic, we get the observability of the network tissue. And while SMI doesn't talk about this, but anybody who's dealt with Istio realizes that Istio also provides all of the reliability features that we were used to expect from all different libraries, such as Hystrix, Finagle, etc., things like circuit breaking, retries, bulkheading. And when we look at any service mesh implementation, we'll see that there is that security component there. And while service mesh interface doesn't talk about this, we'll probably expect that service mesh would provide us with security. And finally, again, especially close to my heart, progressive delivery. All of the techniques of making software releases safe, infrastructure-based techniques for making software releases safe and stress-free, such as blue-green, canary, dark launching, all of the things are today still ridiculously hard to pull off. Yeah, right? We've been talking about continuous delivery. The book about continuous delivery came out 12 years ago. Today, even a junior probably knows what CI/CD means, and still organizations who are doing actual continuous delivery are rare and far between. And that's because these techniques are very hard to pull off. So, progressive delivery. So this was not stress-free, but again, in the end, it was. So finally, as I see it with service meshes, these techniques become much easier to implement. And as I see it, this is the killer app for service meshes. Again, it's from my point of view. Now, there are folks in the industry, and some are very respected by me. For example, Avishai Ishalom, who spoke here earlier, and Mark Burgess, the original creator of CF Engine, who say that the service mesh isn't the right approach to solving these problems. They're saying that actually doing this in the network, in the proxies, breaks the end-to-end principle of computer networking. We're putting too much smarts in the network, and as a result, we're turning our microservice system, instead of a system that is built out of autonomous services, it goes back to being a monolith, which will be eventually harder to evolve and change. They're saying that all of these smarts, all of this complexity should be better put in the application and not in the network. To which the proponents of service mesh say that we've already tried this, and this creates too much cognitive load on the developers, and that's something we should also be taking in account. And well, the truth as I see it is, as always, somewhere in the middle. So it very much depends on your product and on your organizational situation and on your technical expertise. Are your ops more technically strong, or maybe are your devs more prepared to take care of networking issues? So we'll have to decide for ourselves. But still, with all of this, the progressive delivery techniques are much easier done with the service mesh than with anything else. And I'm running out of time. But I'm the last one, so nobody's really waiting for me to finish. So now that you've looked at this, and you maybe said, okay, here is a use case that I really need a mesh for, and I'm ready, I'm brave enough. If you were brave enough to come here, then you're probably brave enough to try a service mesh. I'm brave enough to try a mesh. Which one do I choose? What are the options in this burning hot market? Okay, so first of all, there's Istio, of course. It is still the reference implementation, the most feature complete and feature rich. It supports hybrid configurations, not Kubernetes only, at least the documentation says so, even though we haven't really seen true real-life implementations of Istio outside of Kubernetes, but at least it's supposed to be available on other configurations and other platforms. This is the service mesh that introduced the use of Envoy as a sidecar proxy. Actually, the Envoy is now developed by Google. It's not developed by Lyft anymore. It's known for its performance issues that are mainly the result of some architectural decisions that were taken at the dawn of the project. Mainly, there is a component named mixer that sits in the middle in the control plane and takes all the policy decisions and collects all the telemetry, and it's basically in your data path. Now, the Istio creators are aware of that problem. There is now a new solution called Mixer V2, which is now in beta, which involves taking these filters, and instead of applying them at the mixer, they're compiled at the mixer as WebAssembly modules and then are distributed to the proxies, so then they're applied on each proxy individually. This sounds technologically very interesting, not so sure about how it will work in real life. We still have to see. Istio is known for its complexity. It used to install more than 50 CRDs into your cluster. In version 1.3, this was reduced to 20 CRDs, so we're now better off. And now part of its complexity comes from its very high modularity, its strength and its weakness. So basically, you could start with Istio not installing all of its components. So you could just try it with reduced functionality and then add the modules that you need afterwards. It has open tracing support and Prometheus support, like most of the other service meshes do. Now, the first contender is LINKERD 2.0. This is not the same LINKERD that we talked about in the beginning. This is a total rewrite of the LINKERD with the control plane being written in Go and the proxy being written in Rust. This is, by the way, the only service mesh that has a sidecar proxy that is not Envoy. What LINKERD creators now say that their proxy is much better at what it does because it's their whole solution is targeted Kubernetes only. Like many other service meshes, and Istio was the first one to start with this, they were trying to say we're running on Kubernetes, but we can also provide this anywhere in the world. And that's why they're using Envoy, because Envoy is a generic proxy, a very performant one. It's good for running a sidecar proxy, but it's a generic proxy. While LINKERD has a proxy that's written in Rust, which is a language that is known for being very memory safe and memory efficient. And it's only working with Kubernetes, so it deals with a narrower spectrum of problems, which makes it more performant specifically on Kubernetes. And they have this promise, and they also execute on that promise, as we'll see a bit later. Now, with Istio being the complex solution, the LINKERD is marketed as a very simple solution, which allows us to use it with minimum or even zero configuration. It has telemetry already built in. It comes with a predefined, very minimal installation of Prometheus inside, which allows it to provide high performance and very high operational simplicity. So definitely a solution to look at. Now, if who here is using CONSUL or have used CONSUL? Okay, right. So CONSUL from HashiCorp, many of us use HashiCorp tooling and love HashiCorp tooling. And CONSUL, which used to be a key value storage and then a service discovery mechanism, now CONSUL is a service mesh. It's a full-blown service mesh. Now it has connect as an additional definition of it. Well, the advantage is, of course, it's a battle-tested tooling. It's probably a tool you've used in the past. It has very good support for heterogeneous environments because it's not tied to the Kubernetes stack, and it's very good for creating multi-cluster service meshes. It does use Envoy as a sidecar proxy if you want a sidecar proxy, and it requires you, in addition to that, to install a CONSUL agent on each one of your nodes. And you can use HCL or JSON or even UI instead of YAML if you think that HCL is better than YAML for some reason. Well, it doesn't support collecting telemetry on CONSUL itself, but it allows us to annotate our Kubernetes objects so we can collect telemetry directly from the Envoy proxies if we have them. And regarding the SMI compliance, it only supports the traffic access API. Now for the newcomers, if you don't like running the sidecar proxies, and there are reasons for not liking that, because Envoy notoriously can require up to 1 GB of memory for each one of the proxies. Now, let's say you have 10 pods running on a node. That would mean 10 gigabytes for proxies only. So if you don't like running sidecar proxies for some reason, here is Containers, the makers of Traffic. Who here is using that, by the way? Okay. So Traffic is a very nice load balancing solution, a proxy. Now, definitely Mesh is based on Traffic. Now, one reason why it's not used as a sidecar is because Traffic is written in Go, so it cannot provide the performance of LINKERD or even Envoy. To which Mesh say, Traffic Containers say, we don't want you to run sidecars, you just run one proxy on each node, and we're also SMI compliant, and you don't need to configure us with CRDs, only put annotations on your Kubernetes objects. And well, there is one thing, you won't be able to use the service mesh transparently. So if you want to be able to use the mesh, you'll have to talk to your services through a very special FQDN, which would be service, namespace, and then the magic word mesh. This feels like a little bit of an ugly hack for me, but could be acceptable to you again. But I didn't deploy my services in Kubernetes to be talking to them through an FQDN. Whatever. Now, the last one here is KUMA, or Kong Mesh in its Enterprise Edition. It comes from a company, Kong, the makers of API Gateway named Kong. Now, they pretend to be a universal service mesh, so not for Kubernetes only, but for the whole universe. Again, using sidecar proxy, Envoy as a sidecar proxy. They're talking about being platform agnostic. They don't care about SMI compliance. Now, they're making Kong gateway. Paradoxically, their gateway is based on Nginx. So it does look like they're only adding the service mesh to be able to make their enterprise solution more attractive. So basically, from reading their documentation, and again, I don't have practical experience with that, this to me looks more like a marketing strategy based on a service mesh. But again, I may be wrong. Prove me wrong. I'd like that. And finally, there's this new project from the Cloud Native Computing Foundation called Network Service Mesh. It is not the same, but definitely related. On their website, they're saying that they're inspired by Istio, but they're dealing with traffic not on layer 3 and 4, as Istio and all other application service meshes do. They are dealing with traffic on the layer 2 and 3 level, basically allowing for things like hybrid and multi-cloud scenarios. They're talking about things like connecting containers in different clusters. Now, service meshes do have support for that usually, but that requires additional configuration. They talk about support for exotic protocols, so it's not only TCP/IP, HTTP, gRPC, etc., etc. They're talking about supporting secure tunnels as first-class citizens. And while we're here at a cloud and edge computing day, they're talking about things like dynamic network interface allocation for talking with all kinds of exotic devices outside of our cloud. And basically what we could say about NSM by looking at its spec, it's a new project again, is that it tries to finally replace OpenStack as the default network function virtualization platform for the cloud native edge. Cloud native age. Yeah. Again, what would Freud say about this? Okay, so yeah, we all know that OpenStack is not in a very good condition. Okay, now when choosing a service mesh, it's very important to, when choosing any tech, it's very important to look at its ecosystem. So what do we have here? Here it's very important to talk about a company called Solo.io, which is led by our compatriot Edith Levin. And they're building an API gateway based on Envoy called Glue, and also a number of tools that are very relevant to our talk today to the service mesh tech landscape in general. The main of which is this project called Superglue, which provides something like a management plane for different service meshes, which allows us to install, configure, discover, and connect different service meshes. Currently, they support CONSUL, LINKERD, Istio, and AWS App Mesh, and they integrate with all the major cloud providers. And also this project, or more a community that I already talked about, which is called Layer 5, the Service Mesh community. Have I talked about it? No, I think I forgot. Okay, so this is a community that I joined about 3 months ago. This community is dedicated to promoting and researching this service mesh tech in all its flavors and shades. It has 3 main goals. First of all, discovering and researching the landscape of service mesh technologies, then providing a playground where we could play with different service mesh tech, and also defining and running performance benchmarks to compare different service meshes. And we have a software project called Meshery that's dedicated to the last 2 goals. Now, this community is very much indeed of engineering brain power. So if you, for example, after today decide that you want to be not only a user but also a contributor to service mesh technology, please do connect on layer5.io and start contributing. Istio, being the most popular and most notorious service mesh on the market today, have their own ecosystem. On this GitHub organization called Istio Ecosystem, 2 projects to note here is Admiral, which is a multi-cluster solution for Istio service meshes, and a project called DNS Discovery that comes from folks at Tufin here in Israel, which provides a very nice example of how you can use service mesh with integration testing. So basically what it does is it, during the execution of your integration tests, it collects all the outgoing calls that your services make and creates automatic service entries for the Istio egress configuration that you can then audit and apply in your production systems. So you may want to look at that. Now, benchmarks. So what does it cost us in computing power? LINKERD, trying to prove that they are much better than Istio, commissioned an independent company called Kinvolk to run a benchmark that would prove that LINKERD is better. The folks at Kinvolk were very, very serious about this, so they also published the benchmark, the way they ran the benchmark, and some tooling for running such benchmarks in the future. And they also, of course, published the results of their benchmark. And here are the results. Now, LINKERD is marked with light green on these diagrams, and Istio in 2 different configurations is marked with light blue and dark blue. Even without going into too much detail, we can see that LINKERD basically beats Istio on all parameters, beside the base power of the marketing machine that stands behind Istio, and well, yeah, the popularity. And this is also important to consider. Now, we do, from our short experience with service mesh technologies, we do realize that there is another price there, and that's the price of managing. We now have developers and ops, and there's this new language in which they should start talking about what happens in the networking layer of their systems. And developers don't like dealing with YAML, neither actually do the ops folks, but they don't have much choice today. Anyway, in order to be able to manage this somehow effectively, we do need automation solutions for this. And some projects have started to emerge. Good examples would be this project from Solo.io called GlueShot, which allows us to build and execute chaos testing scenarios on service mesh configurations, based on service mesh configurations. And Flagger from WeWorks, that is basically a canary release controller that works with different service meshes. And it's actually a much more mature implementation of what I tried to pull off a year ago with this canary controller for Istio called Birdwatch. And It's also important to notice that, of course, some people see service meshes as just a missing piece for the platform that Kubernetes was supposed to provide. And the platform is basically the basis for what we envision as the next step of building that smart platform, and that would be serverless. And that's why Istio is an important part of the Knative from Google. And there's a Plonk stack, if you want to be anti-Google, which includes Prometheus, LINKERD, OpenFaaS for the serverless part, NATS, and Kubernetes. So this is the Plonk stack. And if you don't like Google, you should look into that. Finally, how do you get into the mesh if something in this talk convinced you that that's something that you should be doing? So you should probably start with Ingress. If you don't have an Ingress controller or your Ingress controller is not based on Envoy, maybe you should start looking into moving to something that is based on Envoy. Envoy is a very good, interesting, smart piece of technology, and you want to learn how it works if you want to make it part of your stack as a part of a service mesh. Then when you start using sidecar proxies, initially just use them in bypass mode and start collecting telemetry to understand what happens in your network. Once you've done that, you can start running some chaos testing scenarios to understand how a service mesh could break, and probably GlueShot could be a nice project to use with that. Then almost every service mesh implementation allows us to run it on a single namespace first. So that's something probably to try first. That's a good point to start thinking about how your existing infrastructure would work with a mesh, namely authorization, authentication, what certificate authority to use, how you will be controlling and managing change to mesh configuration, how to do troubleshooting around that, how to upgrade from one version of mesh to the next one. This being a very young technology, this is something you will very soon find yourself wanting to do. Once you're ready with all the answers for that, it's time to spread it to the whole cluster. And if that works fine, then we'll start looking at the whole world being one big service mesh, because that's basically looks like where we're going. And that's it.